Hello everyone, this is Dr. Shaik Ruksana Begam working as Assistant Professor in the Department of Electrical and Electronics Engineering from Institute of Aeronautical Engineering, Hyderabad. Today I am here to deliver a lecture on Superposition Theorem. In the Superposition Theorem, we are going to cover what is superposition statement and what are the steps to solve Superposition Theorem and where we are going to solve Superposition Theorem and why we are going to solve. So first, coming to the statement of the superposition theorem, if you see, it is in a linear bilateral network containing more than one independent source. That means a circuit should be linear. Linear is nothing but the output of the element should be of a constant. For example, if we take resistance, the output of the resistance will be of linear. So here we are going to use only linear elements, linear and bilateral network. Bilateral network is nothing but it should conduct in both the direction. If we consider a unilateral network, it will allow the flow of current or whatever it may be in only one direction. If we consider bilateral network, it will allow the current in both the directions. So here in a linear bilateral network containing more than one independent source. Source is nothing but which delivers the energy. So here mainly we'll be considering current sources or voltage sources. So it should contain more than one independent source. Then only the superposition theorem will be applicable. The response in any element. So whatever the response we are getting in any element to the algebraic sum of all responses due to each independent source acting independently. So setting all the other independent sources to zeros. Setting all the independent sources to zero means if it is a voltage source, it should be short circuited. So setting all the sources to zero is voltage source should be short circuited, and if it is containing current source, then it should be open circuited. Note here all the voltage sources are replaced by its internal resistance or by short circuiting or removing the current sources from the circuit. To simply know the statement of the superposition theorem, here we are considering two sources with linear network. Linear network is nothing but containing resistors, capacitors or inductor. So here mainly we'll be using only resistances. So here I am considering the resistance circuit and two sources. So here are the two sources and three elements which are connected in parallel, which forms two meshes. Whatever the currents we are getting in this mesh will be noted as I1 and here it will be of I2. So first step 1 will be, so in this step 1 we have to consider both the sources. So this will be of source 1 and this will be of source 2. By considering both the sources, we have to calculate the currents in each mesh. Here there are two meshes which are denoted with I1 and I2. Here we'll be getting two currents. So by applying mesh analysis or nodal analysis, we'll be getting currents which will be of I1 and I2. In the step 2, we have to remove one source. That means if it is a voltage source, we have to short circuit. If it is a current source, we have to open circuit. So here we are considering both the sources as voltage source. So first we have to remove one source in step 2. For step 2, first we have to remove one source and the network will be as it is. So here as if we are taking voltage source, so I am short circuiting. So here only V1 source will be there. Again we have to calculate the currents I1 dash and I2 dash. So in step 3, we have to remove the other source. See, this V1 source will be short circuited, the circuit will be as it is, and here we have to consider the voltage source V2, and then we have to calculate I1 double dash and I2 double dash. After calculating all these three steps, for the first step we'll be getting the values of I1 and I2. So the step 2 values and step 3 values should be equal to the first step values. That means I1 should be equal to I1 dash plus I1 double dash. I2 should be equal to I2 dash plus I2 double dash. So all these values should be equal to the first value. So in this way we have to solve the superposition theorem. So here, why we are using the superposition theorem? The superposition theorem is useful in electrical engineering for several key reasons. So first reason will be simplifies analysis of complex circuits. So this superposition theorem will simplify the complex circuits. And second one will be it will be applicable for any linear circuit. So first, coming to the first point, it simplify the analysis of complex circuits. See, when a circuit has multiple independent sources like voltage or current, solving it directly by using either Kirchhoff law can be complex. So if a circuit is consisting of more independent sources in a circuit, by using Kirchhoff's law like KCL or KVL will become complex to solve the circuit. In such cases, we are using superposition theorem. So superposition theorem breaks the problem into similar parts by considering one source at a time, making calculations more easy. So wherever we are having more independent sources like more than one sources, by applying KCL or KVL, it will become more complex to solve the problem. So in such cases, we are using superposition theorem by considering a single source at a time, and then we are going to combine all the steps to the first step, so that the currents whichever we are getting by reducing the circuit should be equal to the currents when they are combined to each other. So second step, apply to any linear circuit. So in the first itself, I have already mentioned it is applicable only for the linear circuits. So superposition theorem is valid for linear circuit, including those with resistors, capacitors, inductors and linear dependent sources. Mostly we'll be using resistors, inductors and capacitors. So the output of these resistors and capacitors and inductors will be of linear. So the third point is basics of advanced techniques. So understanding superposition theorem is foundational for Thevenin's and Norton's equivalent circuits. So in the upcoming videos, we'll be going to learn about the Thevenin's theorem and Norton's theorem. So this superposition theorem is the basic step for this two Thevenin's and Norton's equivalent circuits and networks theorems and signal analysis in AC circuits, especially with phasor diagrams. So these are the advanced techniques for the superposition theorem. By learning superposition theorem, we can solve easily Thevenin's, Norton's equivalent circuits, and then those superposition theorems are also applicable for the network theorems and the signal analysis of AC circuits, especially with phasor diagrams. Whichever the circuits having phasor diagram, the superposition theorem will be applicable in those circuits also. So what are the limitations of superposition theorem? So here we can see the limitations of superposition theorem. Only works for linear circuits. This point already have mentioned that it will works only for the linear circuits. So non-linear components like diode or transistors violate this. So this superposition theorem is not applicable for diodes and transistors or whatever the electronic devices are there, it is not applicable. So and not used for power calculations. Only the superposition theorem is used to calculate the currents and voltages. So it is not used to calculate the power calculation since power is non-linear. So power is non-linear, so that we cannot calculate the power by using superposition theorem. So now we are going to see what are the steps to solve superposition theorem. In the second slide itself, I have shown how to solve the superposition theorem stepwise. So here are some steps used how to calculate a superposition theorem. So first we need to identify all independent sources. First thing we have to remember is superposition theorem will be applicable for if the sources are more than one. If the circuit consists of more than one source, then only superposition theorem will be applicable. So first we need to identify all the independent sources. This includes independent voltage sources and independent current sources. So this theorem may include either voltage sources or current sources. So it is applicable for both voltage sources and current sources. So second, select one source and turn off all the other sources. So first we can calculate by using both the sources in on position. So then we can calculate the currents. So in the first step, see step 1, by considering two sources on. So in the next step, turn off a voltage source, replace it with short circuit. If it is a voltage source, we have to replace it with short circuit where the voltage will become 0. So if it is a current source, replace it with open circuit where the current will become 0. So keep only one source active at a time. While solving the superposition theorem, we have to keep only one source active and all the other sources should be either if it is a voltage source, it should be short circuited. If it is a current source, it should be open circuited. So the third step will be analyze the circuit with a single active source. So we have to analyze the circuit only with a single active source. By using Ohm's law, KVL, KCL, mesh analysis or node. Any one of the method is used to calculate the currents in the superposition theorem, either by using Ohm's law or KVL, KCL or mesh analysis or node. Mostly we'll be considering mesh analysis to calculate the currents in the superposition theorem. So, to find the voltages or currents in element of interest due to this single source. So, either whatever the method we can use to solve currents in superposition theorem. Either it may be Ohm's law, KCL, KVL, mesh analysis or nodal analysis. By using any one of the method, we are going to calculate the currents. Next point, fourth point, repeat for each independent source. So, for each case, consider only one independent source active and turn off all the other source. Record the resulting voltage or current in element of interest. So, first if we switch off voltage 1. So if you are having two voltage sources like V1 and V2, for the first case we have to consider both the sources, and for the second case we have to switch off V2 and then we have to calculate the currents I1 and I2 here. Here also we are going to calculate I1 dash and I2 dash. And then for the third step, we are going to switch off V1 and we are going to keep V2 as active, and then we are going to calculate V1 double dash and V2 double dash. So we have to record all the values after calculating, add all contribution algebraically. So add the voltages or currents from each source to get the total response in a circuit element. So we have to add all this I1 dash and I2 dash. I1 dash and I1 double dash we have to add so that it should be equal to the value of I1, and we have to add I2 dash and I2 double dash so that the value should be equal to I2. Take into account polarities and directions. Use sign conversion properly. So first we have to denote, before calculating we have to denote the signs of polarity. We have to indicate the polarities to the circuit. So here is the example problem for superposition theorem. See, in the circuit shown in figure 1, using superposition theorem, find current Ix. So if we assume this current as Ix, now we have to calculate the value of Ix. So what is the first step? First step is to apply superposition theorem, there should be more than one source. So if we consider this circuit, here we are having two sources, which is of V1 and which will be of V2. So here two sources are there, so that the superposition theorem is applicable for this circuit. And then we have to see all the elements should be linear elements. So as I have already mentioned, linear elements are of resistors, capacitors, inductors. So diodes and transistors will not be applicable to solve superposition theorem. So as we see this circuit, in this there are linear elements only which are of resistors. So here there are three resistors which are connected in parallel. So which forms two meshes which will be of I1 and I2. So by applying KVL for circuit as shown in the figure, so this will be the circuit. See, here there are two meshes. In the first step, we have to consider both the sources. So I am keeping both the sources in the on position. So here we'll be getting the values of I1 and I2. By using mesh analysis, we have to calculate the equations for each mesh. So if it is the current is flowing in clockwise direction, the source will become negative. So it will be of, so the equations will be written in this way for the first mesh. So 50 I1 plus 100 I1 minus I1 plus I2 minus 8. So the source will become negative while we are considering the direction in clockwise direction. So if we solve this equation, we'll get the values as 150 I1 plus 100 I2 equals to 8. So same for the second mesh. Here also we are considering clockwise direction. So the equation will become 25 I2 plus 100 I. First, as we are considering for the mesh 2, first we should take the value as I2, then I1. So I2 plus I1 into minus 5 equals to 0. After solving this equation, we'll get the value as 100 I1 plus 125 I2 equals to 5. So we have to consider this as first equation and this will become second equation. From the previous class itself, I have told how to solve this equation by using scientific calculator. So in the scientific calculator, if we substitute all these two equations, we'll get the values of I1 and I2. So after solving these equations, we'll get the values of I1 and I2 as, so I1 will be of 57 milliamperes and I2 will be of minus 5.71 milliamperes. So this will be the first step. So this will be I1 and this will be I2. In the second step, we have to remove one source. So there are two sources which are denoted with V1 and V2. Now I am going to remove source V2. So after removing the source V2, the circuit will be redrawn in this way. So here, as it is a voltage source, I have short circuited it. So here there is only one source which is denoted with V1. So as he mentioned, to calculate the current in Ix, so I have added I1 and I2, which will be 51.3 milliamps. The Ix value will be of 51.3 milliamps. In the second step, first we are going to calculate the resistances. So as here there is only one source, here it is easy to calculate. First we have to calculate the total resistance of the circuit. By considering single voltage, the circuit is redrawn as shown in the figure. And then we are going to calculate R total. So here is the 50 ohms. For this 50 ohms, these two resistances are connected in parallel. So 50 plus 100 into 25 by 100 plus 25. So the value will be of 70 ohms. So our total value will be of 70 ohms. Now we are going to calculate total current in the circuit. So to calculate the total current, we are going to use the formula V is equals to IR. So we already know the value of resistance, which is of 70 ohms, and we know the value of V, which is of 8 volts. So from this we can calculate I is equals to V by R. So after calculating V by R, so which is of 8 by 70, we'll get the value as 0.114 amperes. Now here we are going to apply current division rule. So here current division rule, I will be equal to I total into opposite resistance by. So opposite resistance is nothing but here we are going to calculate the current. This will be the current resistance. So this will be the opposite resistance. So opposite resistance by current resistance plus opposite resistance. So this will be the current resistance and this will be the exact opposite resistance. So by using this formula, we are going to calculate the value of I. See, by current division method, here the total current whichever we got is of 0.114 and this will be the opposite resistance as shown in the figure, which is the value of this will be of 25 ohms and the current resistance value is of 100 ohms. See, 25 is opposite. So 100 will be of current resistance and again opposite. Opposite will be of 25. So if we add this 100 plus 25, we'll get the value as 125. So if we substitute these values, we'll get the value of I1 as 0.0228 amperes. So next, so we got the value of I1. Now we have to calculate the value of I2. In the third step, first we have to remove V1 source and we have to keep V2. Again, we have to build the circuit as same. We should not change any values of resistances. The resistance values will be same. Just we have to replace the sources. So first we have removed V1. Now we are going to remove first we have removed V2 and then we are going to remove first V1 source. Removing is nothing but short circuiting. If it is a current source, then we have to open circuit. So here we are keeping V2 source. Again, we have to calculate the total resistance. So while calculating total resistance, we have to remember the point. From source side itself, we have to calculate. See, in the previous slide, we have seen that so source is connected here. So the resistance 50 will be in parallel with 25 and 100. So in the same way, if we consider this from the source side itself, we are going to calculate the resistance. So this 25 will be in parallel with this 50 and 100 ohms. So what will be the total resistance? Our total will be equals to 25 plus 50 into 100 by 50 plus 100. See, 25 plus 50 into 100 by 50 plus 100. Then we'll get the value of our total. So our total will be of 85.33 ohms. Again, same way we have to apply current division rule. Current division rule I have first before applying current division rule, we have to calculate the total current. See, I total will be equals to, we know the value of resistance and we know the value of voltage. So I will be equals to V by R, which will be of 5 by 58.3. So after solving this, we'll get the value as 0.0857 amperes. So from this, we are going to apply current division rule and then we are going to calculate the value of I2. So here, after applying current division rule, it will be of 0.0857 into So current division rule will be of, so here this is the main resistance and this will be the opposite resistance. So opposite resistance will be of 50 by 100 plus 50. So by solving this, we'll get the value of I2. So I2 is equals to 0.0857 into 50 by 150. So the value of I2 will be of 0.0285. So already we got the value of I1 as 0.0228 amperes and the I2 value will be of 0.0285 amperes. So if we add these two values, it should be equal to the first step value. So if we add these two values, it will be of 0.0513 amperes. So if we move for the first step, so this is in milliamperes. If we convert this into amperes, 0.00513. So this is what the value we are getting after solving those two steps. 0.0. So this is about superposition theorem. In the next videos, we are going to solve more problems on superposition theorem. That's it for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.